Oh man, JB's really been stepping up on his lighting. I don't think it's better than mine yet, but it looks really good. I gotta step up my game. How about, what can we do? Nanoleafs? Yeah, Nanoleafs. That'll do it. That'll be the game changer. All right. I wonder how much that's going to be. I'll price that out here. Good old nanoleaf.com. Nanoleaf.me, whatever it is. Shop. Shapes. I want hexes. Everybody does triangles. I want hexes. Hexes look badass. Starter kit. Power supply. 7 panels. Why is there no price? That's not good. And I'm going to need more than 7. 3 panels or 25? Well, clearly I go 25. Twist my arm. Be sure you have enough PSU. All right, we'll deal with that later. Add to cart. And let's see, 2 power supply units, they said. Oh my God, $780? I better call the wife. Hey, hon, how's it going? Good. I was thinking about stepping up my live streaming, like lighting situation. More LEDs. Yeah, no, I got a lot as it is, and yeah, I think it looks pretty good. Just, I don't know. I think the back wall needs something. It's kind of vacant. I was thinking about getting some Nano Leafs. Yeah, they're these really cool geometric shapes. They're really diffused LEDs. You kind of snap them together, order them however you want. It's kind of organic looking. They're a little on the expensive side. Well, I mean, the starter kit's $200. It's only 7 panels, though. Yeah, obviously I need more than 7 panels. Well, they got a 3-pack or a 25-pack. If $530? $530. $530. Yeah, it'd be like, and then I need another power supply for it. Like 780-ish bucks. Yeah, you're right. You're right. I just needed to, just a logic check on this. Yeah, that is an awful lot for something that I make absolutely no money at. Yeah, I know. YouTube's stupid. I know. It seems like another job. I have fun doing it though. Yeah, you're right. Yeah, you're right. I really can't justify that. Is far too much cash for some RGB LEDs that kind of snap together in a real cool shape to make my live stream look better. Yep, you're right. It's ridiculous. Forget we had this conversation. Yep. Okay. All right. Love you too. All right. No, I'm not gonna buy them. I don't know. I mean, I'll see if there's other options. All right, fine. I'm not gonna buy them. I told you I'm not gonna buy them. Look, I you. I wasn't gonna buy them. Oh, all right. Okay, bye. I knew that was a bad idea. I've got 3D printers. RGBs are pretty damn cheap. I wonder if I can make something. All right, folks, welcome back. So today we're going to do a little project. This is not quite FPV related-ish. It's kind of, sort of, but not really. I'm going to make my own DIY nano LED panel system. I've been working on this for quite a while, and I am ready to put it all together. This is from the ground up, my own design, from 3D prints and the design, everything. It's very simple. There's only a few pieces. LEDs, a controller, and the 3D prints, and a power supply. Not a whole lot to it. Maybe a dab of glue here and there. Didn't go through a whole lot of filament. Maybe a roll of PLA and a roll or two of PETG. I like PETG just because, you know, PETG's for the real printers. PLA's for the scrubs. So we're gonna use some PLA today. Here are the parts that we're gonna need. All right, so what we're gonna need is we're gonna need a bunch of LEDs. I've got 4 rolls of LEDs. This is 1,200 individual LEDs. These are 12-volt LEDs. I'll put a link to all the parts I'm using in the video description. So 1,200 LEDs, it's a lot. These are running 12 volt. They are individually programmable, and there are 30 LEDs per meter. They're pretty dense. They're not the densest in the world, but there is a bunch of those. We're gonna need some way to control the LEDs. For this, I picked up a Dig Uno board. This is a pretty neat little thing. It uses wled. It's an open source LED controller software on this ESP module here. And then it has a power distribution board. Basically, it takes in 12 volts from my power supply, kicks out 12 volts and a signal, a 12 volt signal for the LED control, and it is programmable over the Wi-Fi's, and it is all open source and adjustable in any way you want. Again, this is all open source. Put links in the video description. We need some 3D prints. So I have gone with a hex design. For some reason, I'm attracted to the hexagon look. This is each of the hex. It looks like this, and we see we have a channel in here for those LEDs, and then I have a separate hex. These are going to go on my design. This is where the LED controller board is going to be housed. And then to join all this stuff together, I've come up with a really nice little interlocking system using these little press-on locking joints. So if you have 2 panels to each other, you're gonna just press that on there. And if you have 3 panels adjacent to each other, there's a different design that goes right like so. And this design, I'll put it on Thingiverse for you. Anybody can use it. Feel free to alter it however you want, and you know, sky's the limits as far as you want to do this. So that's the housing for the LEDs, and then diffusion. Diffusion's like the biggest. Diffusion's like the biggest part of this thing, because if you have really hot spot LEDs, it's going to look terrible. So I made a diffuser. This is printed out of Overture matte white PLA. I'll put the dimensions and the specs on the screen here, and these just kind of press fit into the hoops. Some fit better than others. Probably won't need any glue or adhesive on this, but a little drop of E6000 on the looser panels will certainly work well. Fits a little bit different. I had 2 machines running, had my Prusa burning away all day long, printing these things out. Actually, my Prusa was printing these because I have a satin sheet for my print surface, and that will be the outer layer for the diffuser, so keeps it all kind of looking the same. You see 0 layer lines because of those really nice Prusa textured sheets. And then my Voron 2.4 was kicking out all the hoops in an alarming speed. That thing was just slanging plastic like there was no tomorrow. So I had to kind of figure out what the general size of the panels were going to be, and basically I made it so I could fit 2 hexes on a sheet of paper, took them over to the laser, and just started making paper hexagons, just a big pile of them. Yeah, I could have used scissors, but hey, you know, when you got a laser, you do laser things. It certainly made the work a lot quicker. I had to figure out a pattern. Like, how do I want this thing to look? I knew I was going to do hexes, and I picked a size of a hex that I just randomly liked. So I went and printed out a bunch of pieces of paper with the size of the hex, cut them out, taped them together, put them on the wall, just to kind of get an idea of how big it is and what design I like. And I put a vote out to my community, my Patreon members over on Discord. If you want to be a part of that group, click the link in the video description and join the Cool Kid Club. You get access to my Patreon only section of Discord. This was going to be the pattern we're going to go with. So fired up old Fusion 360 and just started sketching away, making plans, making a channel for the LEDs to kind of ride on the inside of the hoops. Had to cut out the little feet so we could actually attach things together, extrude it all out, and make a top plate for it, and we were good to go. So this is the pattern we're going to come up with. It ended up being 39 individual tiles. The only ones that won't be lit are these 4 for the prop nuts, right? And then these 2 in the center, just as, you know, the typical FPV quad lightning holes, arbitrary lightning holes that we come to know and love. The idea is to run all the LEDs continuous with no breaks. The WLED software allows me to assign certain groups of LEDs to certain functions. That'll come into play in the end here when we start programming all the LEDs. So we had to pick a start point and we have to pick an end point. Actually, we just have to pick a start point. And the trick was to cover the inside of all the hoops without doubling over and without having to make any cuts and splices, or as few as possible. Now there is going to be enough LEDs in this where I need to tap power in somewhere else, somewhere halfway through the run, because even though these are 12 volt, they run a lower amperage. 1200 LEDs is a lot for one power tap. So just playing around with them on the floor last night, putting an extra power tap at about 600 LEDs really worked out perfect. So that's what we're going to plan on doing. We're going to hide the electronics or splices or whatever we got to do in these blank spots so we don't really see them. There's still going to be a cord coming out of this because, you know, nobody's invented wireless extension cords yet. Or have they? No, I don't think so. Anyways, so that's the plan. Let's go ahead and start putting everything together on the floor. It's going to take a lot of space. I'm going to have to do this all on the floor, so bear with the terrible lighting on the floor. Damn, short one. All right, we got it all put together. It's upside down because this is going to work out the best for me for routing all the LEDs. I left enough gap where we can take an LED strip, loop it over and under without having to make any cuts or splices or anything like that. So we're just going to have to follow the diagram that it came up with. This diagram here, we got our start point, and we're just going to follow the lines that I made to hit all the loops without having to repeat anything. There will be a few crisscrosses here, like this, but we should be able to do all of this without making any cuts, which I'm super excited about. We'll see if it actually works out that way. I have a bad feeling that I have underestimated this beast of a project here. All right, all wired up, or at least all the LEDs are ran, and we actually had quite a bit left over. I think I probably used 3 and maybe a half strips. So now we're gonna have to get over into this part here, which is where all my electronics are gonna be. I actually wanted to be in that one, but you know, flipping things over
you know, makes a fool out of me. So the Dig Uno is going to go inside this box, and here is my end, and here is my start. I'm going to put 12 volts into this and 12 volts into this to try to help balance the load throughout the entire LED array here. And then we're going to have to count back from 1200 minus however many are in that mess there to program the WLED controller. So I'm going to flip this thing over and hopefully don't break anything. I need to print out a few more of these little corner connectors. Apparently I'm missing a few. And I'm going to have to solder up some leads and wire up our array. All right, so we got our connections to our Dig Uno board here, ground, power, and then we have our 2 signal lines, which are going to go to LED 1. This board can control 2 separate lines of LEDs independently of each other. Now, the reason why I've got both of them going to the same pad there is, see, we've got ground, 12 volts, and then we got B0 and D0, and it's a fallback in case one of these lines gets cut or there's a failure in a line, then there's a fallback signal wire. So these LEDs basically have one line of redundancy just in case. So they both go right into that same port there. And if we wanted to run a separate instance of WLED on a set of LEDs, we can connect it to the LED 2 pad. And our 12 volts is going to go into here. Okay, we got all our power connections done. Main power leads, 12 volts coming in here, and then these 2 here daisy chain to the end of my run here to supply an additional 12 volts into the line. Hopefully that'll work and I don't need to run wires up to there or somewhere to splice in for extra power. But if you see like a dim gradient going across, it's because it's running out of voltage through the lines here. So what we're going to power this with is just this old 12 volt power supply I've got here. I think this came with my old TiVo Tarantula or something like that. So 12 volts, 20 amps. These things are a dime a dozen. I added a fan to it a long time ago. It really doesn't need it. But we're going to power it with that. And I've got a handy dandy little watt meter here just so we can see the specs of what's going on. So let's go ahead and fire this bad boy up. All right, so just to demystify this, I already programmed WLED for 1200 LEDs. So obviously we've got less now, just because I wanted to test the strips before I bothered doing any of this stuff, which they all came in just fine. And here we go. We've got 12 volts coming out of the power supply, 12.15. I don't know how accurate this thing is. It's you know, good enough.
A few moments later.
And presto, hot damn, look at that. She is good to go. And there we go. All good. Everything's working. No mess. Everything's working perfect. I could not have asked for this to work out better. I'm shocked. I am glad this is working exactly the way it's supposed to. Exactly the way it's supposed to. Time to put in the diffusers. A big old stack of these things.
As you can see, some of the diffusers fit better than others. They don't fit perfect. Some are tight, some are a little on the loose side. The loose ones, I'll eventually come back around with a little dab at E6000 on the backside and stick them on there. I'm trying to be really careful to make sure the textured side is out. The textured side was the side that went towards the build plate. This matte white PLA from Overture is really good stuff, and the Prusa just does such an excellent job. I can hardly tell where the layer lines are versus where the textured side is. And the last thing I had to do is print out some black hexes to fill in the blank spots. Well, that's it. That's the LED wall project. I'm really happy with it. It turned out way better than I thought it would, especially since it's literally all 3D printed stuff. Some LEDs, some electronics, a little bit of soldering, some wire, and some wall hangers. Man, you're good to go. I do like the way it looks, but I'm not going to leave it there. I'm going to end up rearranging the whole background here, and it's going to probably go over in this dead space here. I didn't realize that my my boom arm was going to be kind of in the way of it, so we got to work on things one step at a time. But I love the fact that it works. It works perfectly. It looks really good. I have it segmented out so that the props are their own separate segments, so I can control those 4 independently of the body, even though they are not in order. Like these couple top LEDs and are the end of the entire run, and these are the beginning of the entire run, and it kind of controls them all as one group. And the WLED software can run on the browser, can run on your phone, and it's easily configurable. I'm just clicking through some random profiles I pre-made. Yeah, this is so good, and it's also integrated with my live stream. So if you put the special chat commands in there, it'll do its thing and control the lights. Super happy with this project. Big shout out to House FEV for giving me some good advice on the Dig Uno and things to look for as far as what types of LEDs, the power requirements, that kind of stuff. Super big thank you for that. Probably couldn't have done this without you, or I probably would have. It probably would have taken a lot longer. I probably would have given up. All the stuff I used in this project down in the video description. Affiliate links, obviously, this is the whole YouTube thing. Affiliate links for all the stuff in there. Buy anything we want from those vendors, and I'll get a small commission. It's an easy way to help me out. If you really want to support me, go to tweetfv.com, click the Patreon link, and support me over there. A couple bucks a month. If this content's entertaining, you enjoyed it, you learned something, or you just like hearing me blab on and on, if you want to give back just a little bit, a couple bucks a month, it's pennies on the day. I would greatly appreciate it. All right, folks, let me know what you think of this. Man, if I can figure out how to point to the thing. Let me know what you think of this whole thing right here. I really want to know what you guys think. I enjoyed making it, and the fact that I didn't have to do any cutting and splicing, it just adds to it. All right, folks, thanks for stopping by. Thanks for checking this out. And as always, stay positive. See you next time.